Muy buena gente, ¿cómo están? Muy buenos días. Ya está a puntito de comenzar el directo oficial, como ven. O sea, ahí empieza. Estamos a tiempo menos 27 minutos para el lanzamiento aproximadamente.
Good morning and thank you for being with us on Road to Space. We are going live on the 20th mission of the Vega launcher. In 30 minutes, the European spacecraft will take off with 3 CERES satellites on board. That's the first European electromagnetic intelligence space system. It's packed with high-end technologies and it's been developed by CNES for the General Directorate of Armament. But before that, let's take a look at the agenda. So today in Road to Space, an outstanding liftoff, the Vega flight, Flight 20, that will take off in a few minutes from the European Space Center in Kourou. So we're live in Kourou, but also in Paris with our experts. With them, we will decide for takeoff, and you will learn more about the passengers on board the launcher. 3 satellites. Yes, we have 3 satellites that will fly on 2 different orbital planes to design a triangle geometry. CERES is the only electromagnetic signal intelligence system, a revolution for our armed forces, 20 years of research between CNES and the Ministry of the Armed Forces. A launch is always a moment full of emotions for the teams. In our live show, new reports on how these satellites were designed and also information about the ground segment. This is the special room for the satellite. Welcome to Road to Space, the show where the present is connected to the future. So today in Road to Space we have reports for you, but also experts with 3 guests on our sets. Samuel Rogers, you are with us, you're specialist Vega for Arianespace. You are going to help us decipher the features and the challenges of this mission. And then later, we will have Hervé Grandjean, spokesperson for the Ministry of Defense, and Philippe Steininger, the defense advisor for CNES. But right now, let's see what they're doing in Kourou. We have all the teams from Arianespace, CNES, DGA, Airbus, Defense and Space, and the European Space Agency. They're getting ready for liftoff. But we are going to be able to talk to Stéphane Israel. Hello, Stéphane. Welcome to Road to Space. Good morning. Thank you for being with us. It's very early in Kourou. It's not 6 o'clock a.m. I see all the teams ready in the Jupiter room. Can you give us some information about this launch that we're all waiting for? Yeah. So this is a very important launch. The CERES program includes 3 satellites, as we just said. It's a program that we operate for the Ministry of Defense, along with the General Directorate for Armament. So it's a sovereign program, and it combines Airbus, Defense and Space with Thales and Thales Alenia Space. So it's a French team that came together for a strategic program. So very important passengers, very important partners. You know them well. Can you tell us a bit more about today's flight? Yeah. It's a bit more than 6 o'clock a.m. in Guyana. At 6:27, our light launcher, Vega, is going to lift off. This mission is going to last 56 minutes and 44 seconds. It's to the north. We have the first stages that will separate, and then we'll have the AVUM that will have 2 boosts, and at 700 kilometers in altitude, after 56 minutes and 44 seconds, we'll have the jettisoning of the satellite. It's not my first launch, and each time, whether for you or for us, it's always a great source of satisfaction. But this flight is a bit special, isn't it? Yes. It's a lot of satisfaction, a lot of concentration, and it's full of round figures tonight. It's flight 20, and it's the 300th flight launched from the Kourou in French Guiana, from all our family of launchers, Ariane, Soyuz, and now Vega. So that's the 20th Vega flight and the 300th flight from Kourou. Okay, thank you very much, Stéphane. We give you time to focus, and we'll get back to you a bit later. So, of course, we'll be in touch with Kourou all along this flight so that we can follow every single step of the launch. Liftoff at 10:27:55 seconds to be very accurate, and we see that all the teams are very focused in Jupiter. Samuel Rogers, you are the Vega specialist for Arianespace. You're very familiar with the place. You went there. So what? Well, it's always very emotional, you know. I usually take part to launches in the bunker, so that's the location that's the closest to the launch pad. So you're not in the Jupiter room. No, there are many teams. Some of them are in the Jupiter room. I was in the bunker, in the launch bunker. So we are very near, but we are sheltered underground, and we feel everything related to the launch. So that's great. Okay, what do you feel when you get there? There is a combination of many different emotions. There is some level of stress because we do realize that it's a beautiful human and technical endeavor that brings us to the launch pad. So we can't afford to neglect any detail. So there is a lot of stress and a lot of pressure. But there is also very high concentration. Everybody knows exactly what they have to do, so everybody is very much focused and very much involved. And as Stéphane said, there is also great joy when we see that this is, well, the end of several weeks or months of work for all the persons involved in such takeoff. Okay, so before we take part in this live takeoff, we are back in Kourou with Marino Fragnito. Are you with us, Marino? Yes, I am with you. Hello, Marino. You are director of the Vega business unit at Arianespace, but this is a non-traditional, non-typical mission. Why? Well, this is a mission on which we've worked for many, many years. As Stéphane just said, it was very much teamwork coordinated by Arianespace, but also involving CNES, DGA, Airbus Spain that helped us build the jettisoning system for the satellites. We worked together for many years. We carried out many verifications during the development phase because we have a jettisoning system which we call a clip, and that's very specific for CERES. And we also worked in the avionics that were developed specifically for this mission. So we have a very narrow separation margins for the satellite, so we had to check that very accurately during the development phase. That was very accurate work for all our teams, and we're all there very focused for the success of this mission tonight. Okay, so it's highly technical. How can you prepare for such a technical mission? What's different? Well, as I said, the system is to jettison the satellite is optimized. I will tell you more about the mission during the show, but we have a network of telemetry stations, which is not a standard network. We have a boat that will acquire telemetry data along the path of the launcher. So we've accumulated various requirements that were complied with through the setting of non-standard systems, and all this required huge efforts on behalf of Arianespace and of our teams. Well, thank you very much, Marino. We'll be back with Samuel. We're back with Samuel to talk about all this. We talked about a boat, we talked about a sea-based telemetry station. So this is an outstanding mission for all the teams. You're our expert tonight. Can you tell us the specificities of this flight? It won't follow the same trajectory. We have an animation. Can you comment this? And I learn a lot, so we should have a video animation and you'll be able to make comments on every single phase. Yeah. So it's going to be a launch from the Guayana Space Center. It will be triggered with the ignition of the P-80. That's the first propulsion stage of the Vega launcher. It will push for 10 minutes and then there will be a separation order and the stage will be separated. Then the launcher will be pushed by the second stage called the Z-23 and it will burn and then be separated. And then the Zefiro 9 will be in charge of pushing the launcher. This is what we see now on the screen. Zefiro 9 will work for a bit more than 2 minutes. And during this phase, this is when we jettisoned the fairing that protected the 3 satellites when the launcher was going through the atmosphere. And that's when we have acquisition by the boat-based telemetry station that Marino just talked about. Yes, we'll talk about this some more later. Okay, and with this boat-based station, we will know in real time about all the events that will come afterwards. So I'm talking about the separation of the third stage, the Zefiro 9, as you can see. That's a slightly specific maneuver to separate this stage. And then the first ignition of the upper stage, the AVM. That's a very special stage because it works with liquid propellants. And then we'll have a ballistic phase that will take us above Australia. That's when the AVM will be ignited for the second time. Then it will be extinguished. And that's when we'll have the jettisoning of the 3 CERES satellites. As Marino said, it's a bit specific because we have to release or jettison the 3 satellites at the same time. And all this will last 50 minutes, roughly. And then we have a last ballistic phase that will take us above Canada. And that's when we will have a last ignition of the AVM to decrease the altitude of the remaining part of the launcher and finish the VV-20 mission. Thank you very much for all this explanation. We will see that live in a minute, and we are connected with Kourou, and we will remain connected to all the very precious information that you will hear from Pépin Antoine Guillaume, the operations director known as the DDO. And I'm delighted to hear that this DDO was Pépin Antoine Guillaume. And in a few minutes, he is going to announce the final countdown. But behind me, we have this green board. Can we say a few words about this green board, Samuel? We all keep an eye on it, don't we? Yes, we can say a few words about this. This board shows the status of every subsystem required for a successful launch. So here, everything is green, so that's very good news. It's a bit like for traffic lights. When it's green, you can go. When it's red, you have to stop. So we all agree if there was one line that was to move to red, we would stop the final countdown. Yes, absolutely. So at the bottom with the weather, is it important? Yes, we have 4 categories of information that we need for the launch. So at the top left, you have everything related to the base. Bottom left, this is the connection with the launcher, telemetry, geolocation, etc. Then top right, it's everything relating to the passengers, and bottom right, you have the weather And of course, we do monitor all kinds of weather-related risks like thunder, lightnings, etc. So everything's green. We had the latest weather forecast a few minutes ago. Okay, so we took a look at this board, but before we reached the green light, we had a whole campaign, and we have a video that shows that everything starts on water. Absolutely.
Ahí están
Yes,
mostrando
because
imágenes
most
del James Webb. Recuerden
parts of
que
the
lo
launcher
lanzará
arrive by
Arianespace
sea, so they're offloaded in
en el
Kourou, then
cohete
they're
Ariane
driven
5.
to the CSG, the first
Se lanzará el
stage, the
18 de
P-80.
diciembre.
Arrives first with a mobile platform. It's placed on the launch pad. It's hoisted and placed in the mobile gantry. That's the second stage, Zefiro 23, which is hoisted on top of the P-80 and then integrated. So we make this assembly of stages. Then the Zefiro 9 is hoisted in the building and integrated on the Zefiro 23. Then we have the AVM that comes in a container, and then it's integrated on top of the Zefiro 9. For the satellites, they arrive in dedicated containers and they are prepared in specific buildings. We're talking about white rooms, aren't we? Yes, under controlled atmosphere. Absolutely. And there is a certain number of operations that are required, like filling them up with fuel, for instance. And then we have mechanical and electrical checks before they are placed on what we call the clip. That's the special platform for these satellites. Then the fairing is put in place. The fairing is going to protect them for the next phase and for crossing the atmosphere. And that's the upper composite. The upper composite is then placed on a mobile platform. It's hoisted at the very top of the launcher. It's integrated on the AVM. All these very specialized missions, but our teams are trained. Then we remove the gantry and the launcher is ready for launch on the launch pad. Thank you very much indeed. Let's take a look at what there is in the upper part. CERES. CERES is a technological challenge, but also an industrial challenge, the result of many years of research and experiments that were carried out with DGA and CNES. And that's great because as you were commenting the video, we have Hervé Grandjean, spokesperson for the Ministry of Defense. Hello, hello. And alongside with you, Philippe Steininger, defense advisor to CNES CEO. Thank you, gentlemen, for being with us.
Now, together, we are going to try and understand the issues and challenges of today's mission. I'll start with you, Philippe Steininger. You work at CNES. You are the military advisor of its CEO. What are the links between the space and defense sectors? Well, first, there is a very strong historical link, and today we can only see that there are two facts, space programs and
Estamos a
activities,
tiempo menos
or
10
at least
minutos.
most of them have dual applications, both civil and military applications, and also the defense of our societies today comes from the space, and the space cannot not be defended either. So I could say that there is no defense without space, but no space without defense nowadays. And of course, Hervé Grandjean, I'm going to also ask you to tell us more about the use of these satellites in the field of defense. What is going to be their use? Well, satellites are absolutely necessary to carry out military operations. Let me give you an example. In April 2018, we launched an operation to strike the chemical plants used by Bashar al-Assad. To do such a mission, you need in advance intelligence, pictures of the precise locations of these plants, and that's why we use military observation satellites to obtain these pictures. And when you start the air attack with jet fighters that take off from the Saint-Dizier Air Base. You have a constant radio connection with the pilots thanks to military telecommunication satellites, the Syracuse satellites, and once the missiles are launched, they are guided by geocommunication satellites. So you see that you cannot carry out a big military operation nowadays without this capability, so it's important to use what's above our heads. Now, let's immediately watch a video in which we're going to explain to you how the intelligence capabilities of the armed forces in the field depend upon these satellites. France has launched into the space conquest from the beginning of the 60s. Since then, military space programs are a national priority for observation, telecommunications, and many technologies have been born thanks to the industrial and technological efforts supported by the Ministry of the Armed Forces. The new space strategy for defense is increasing these capabilities and enables France to have some of the best space assets in the world. Now, there are systems in Europe that detect from the space, CERES, to have the capability for space-based electronic signals intelligence program. It complements other existing sensors. So CERES is about 700 kilometers high to access areas that are not accessible by other land-based conventional sensors. You have a better knowledge of the enemy operational capability and also the possibility to develop electromagnetic countermeasures. If you know the enemy radars, you can optimize the trajectory of the air attacks. And these capabilities are implemented by the High Space Command under the authority of the Joint Chief of Staff to conduct military operations, which is at the core of French defense. CERES is a constellation of 3 military satellites rotating around the Earth at about 700 kilometers that can collect data everywhere in the world, in a very populated area or not. Radars transmit electromagnetic signals that are picked up by CERES satellites, and they are used to produce intelligence. It is the simultaneous use of the 3 satellites information that makes it possible to locate the transmitter. When a radar transmits a signal, the 3 satellites don't get it at the same time, but with a slight gap. And it's by cross-checking the data collected by the 3 satellites that it's possible to accurately locate the transmitter. The data, once they are analyzed, can provide the technical characteristics of the radar. This precious information is used by the Demeter information system that provides sophisticated intelligence to really identify the transmitter. CERES is an incredible technological adventure. It is DGA that has developed this unique system in Europe in cooperation with the armed forces, CNES, and industry. To develop this system, we've had to really take up a lot of challenges. It's a real technical prowess, and we made progress step by step thanks to 4 demonstrators to test the orbits. The first demonstrators, Cerise and Clémentine, showed that it was possible to detect radars from space, and the next one, Issa and Elisa, helped us develop new technologies that will enable CERES to characterize and locate accurately all types of transmitters, and that's how the CERES program could be launched in 2015. This was done under the leadership of DGA in partnership with the armed forces, CNES, and Airbus and Thales. All these demonstrators validated all the technologies that are embarked in CERES today. In an area like France, hundreds of transmitters transmit simultaneously all types of radars, airport radars for air traffic control, weather forecast radars, maritime radars. So we needed a super sensitive system to detect all these types of transmitters and characterize and locate all these radars. So this is really important to have CERES and all these electronic components to really process a lot of information at the same time. Another challenge with CERES is formation flight. Another prowess achieved thanks to CNES, and they are responsible for the ground segment and also for station keeping. In order to obtain these performances, you have two very close orbital planes, and the satellites are injected simultaneously by the launcher on these two planes with specific maneuvers that require several months of work. After that, the satellites are maintained precisely in this configuration. So it's an industrial and technological prowess, the result of all the investments made for years by the Ministry of the Armed Forces, which increases considerably the ability of our forces to collect intelligence on theaters of operations and to enable France to take better decisions. In a few minutes, we're going to discuss CERES again, but during the story, we heard the DDO announcing the beginning of the countdown 45 seconds ago. So what's going on? Yes, he confirmed the beginning of the countdown. It's an important step because it's the beginning of the last phase that prepares liftoff and is going to give its autonomy to the launcher. Status panel, all right? Yes, everything is green. I want to ask you a question about the satellites. Can we talk about spy satellites? Well, intelligence satellites. Until now, we could take pictures of the Earth with our CSO military satellites. With CERES satellites, now we will be able to capture electromagnetic transmissions. Why is that important? Well, when you want to collect intelligence and find out what type of ship is in the China Sea or the Mediterranean Sea, we listen to the waves produced by the ships you are monitoring, and they are specific to every type of equipment. Russian ship is not like a Chinese radar or an Iranian one. And when we compare this data, we'll be able to know exactly what ship and nationality we are dealing with. And before that, we didn't know that. We had no satellites to listen to that, not in the electromagnetic field. We only had demonstrators, prototypes. We were training, we were testing these technologies, but we were not using them in our military operations. With CERES, as of next year, we will be able to use the intelligence from CERES for operations in the field. So it's a major change. Now let's refocus on the launch. But before, we had to ask this information from our neighbors beforehand. Yes. Before launch, right? Absolutely. So what does it mean? Well, less than 1 minute. And it makes it possible to prepare all the teams to the most important seconds, 0 minus 1 minute. So it's the period during which everybody is very concentrated. So let's watch and see the launch, and then we'll talk together again. We see Vega on the launch pad in Kourou 45 seconds before liftoff. Now, it's always a very important moment for the teams and even for us on the set. Now, let's watch and listen.
30 segundos. Vamos a ponerle el mango.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Hasta el despegue del cohete Vega.
Propulsion est nominal, le guidage est nominal. Paramètres bord sont normaux.
These are impressive images. I'm always impressed, and it's incredible to see that full daylight, no clouds today. It's absolutely wonderful. The Vega launch has been flying for 45 seconds. So acquisition by the Saint-Jean station, and that's the 12th launch for the year for Arianespace. A perfect launch so far. So we've just heard acquisition by Saint-Jean. What does this mean? It's a telemetry station based in the west of Guyana, and as the launcher is in altitude thanks to the P-80 stage, we have acquisition by this station so that we have contact with the launcher for the first phase of the flight. The P-80 is the first stage, okay, and in 40 seconds it will be separated from the rest of the launcher. Yes, it's active for 2 minutes roughly, and once it's finished its a boost and it's empty, we separate it. Okay, so it's very fast. Yes, it takes off very fast because we have 230 tons of thrust that's delivered by the P-80, and you have to look at this in relation to the weight of the launcher, which is twice as low. So it's an impressive thrust, and the launcher takes off very fast. Yeah, these were impressive images. You can see here the separation of the P-80. It's been confirmed. And we see that the Zefiro 23, look at the P-23, the P-80 that we can see, and now we have the Z-23 that continues this thrusting. Why several stages? Why several engines? Well, the principle is to get rid of dead weight when you don't need it anymore. So when a stage is over and has consumed all its propellants, if we keep it on board, we carry dead weight in space, and that's costly. So that's why we have different stages in a launcher, so that we can get rid of dead weight as we go. The trajectory is nominal, says the DDO. It's incredible. After 2 minutes, we can still see the launcher. Yes, it's normal. We've gained in altitude, but we're still not far from Kourou in terms of geography. But soon now, we will have acquisition from our next monitoring station in 20 seconds. Okay, that's the end of thrust by Z-23. That's coming to an end, and we will have the separation of the second stage. Okay, we see the Jupiter room live. So next steps. So now we have roughly now in a few seconds we have the separation of the third stage and the ignition of the Zefiro 9 engine. It's been confirmed. And separation, jettisoning of the fairing. So these are computer-generated images, but say a few words about the fairing. Why a fairing? What's the role of a fairing? It protects the satellites when the launcher goes across the atmosphere because, well, this trajectory generates acoustic forces and many different things. And by the way, it also protects the satellites from the natural environment in French Guiana. But once we are across the atmosphere, we can jettison the fairing because, once again, that's dead weight. And as we're no longer in the atmospheric layer, there is no friction anymore, so the satellites no longer need to be protected. Absolutely, that's correct. DDO said nominal, everything's nominal, so everything's fine. Let's say a few words about what we talked briefly earlier. Tell us about the trajectory, which is slightly more eastward than usually. Why? Well, it has to do with the orbits that we target for the CERES satellite. It's inclined with regards to the equator. So to target this plane, we have to launch slightly more eastward than in the other Vega missions where we launch to the north. But here we launch slightly more to the east. Okay, so that's a different trajectory leading to special measures. Everything's nominal. Yeah, keep an eye on what the DDO is saying. But the launcher is connected to the ground and to different telemetry bases. And here we have one very special telemetry base, which is on board a ship. Yes, absolutely. Because of the trajectory, because we have to launch to the east, at one stage we're flying over the North Atlantic and we have no station available on ground to ensure contact with the launcher. That's why for this mission we deployed, like we did for other launchers, we deployed a boat-based station. So that's a boat that's in a very specific location that's ready to acquire all the signals from the launcher and to maintain connection with the launcher during this phase across the Atlantic Ocean. So we can see that on the animation. Z9, Zephyro 9 separation has just been confirmed. Okay, that's another very important phase. We have 50 minutes flight. Yeah, we have 40 minutes left. We have a reorientation maneuver before we have the ignition of the upper stage. Okay, this upper stage contains our 3 passengers. Yes, absolutely. Reorientation maneuver. Why? Because for the separation of the 3rd stage, we give it an angle in order to make sure that there is a proper injection. So the orientation maneuver has just been confirmed. Can we talk about this AVUM stage? What does AVUM mean and what is it? Well, it's a different stage. It's liquid propellant. So we just had confirmation that it was ignited, so everything's fine. The AVUM, you are connected directly live with Kourou. Yeah, maybe I should have said it before. Okay, so the AVUM is very specific because the propellants are liquid propellants, and we can ignite it at various moments. So it gives us lots of flexibility so that we can target different orbits, and unlike the other stages, which you can't switch on and switch off, here we can. Okay, we will talk about CNES if you don't mind, Philip Steininger. CNES celebrating its 60th anniversary. Absolutely. Next month we will celebrate the 60th anniversary of CNES. Okay, so it's not a secret. We met already, you and I, and we met with you at CNES in order to talk about the history of CNES and how it started working in the space industry. A few days ago, one of our journalists went to Paris at the CNES headquarters in order to celebrate the 60th anniversary of the French Space Agency. He met with 2 of the major pillars of CNES, Lionel Suchet, the General Executive Manager, and Philippe Steininger, who is the defense advisor to the CEO. Hello, Lionel Suchet. Hello. What's CNES mission? We have several missions because we are the French Space Agency, so we have a double hat. We're an agency and we're a technical center. That makes a difference between us and many space agencies throughout the world, but that's an asset for us. We are there to imagine the future of the space industry, to imagine actions to develop the space industry in France and to develop the space ecosystem in France. So what's the role of CNES at international level? We have a long tradition of international cooperation in the space industry. Space is very important in terms of diplomacy, and today we cooperate. We have partnership agreement with more than 70 countries. So we see that space is increasingly important. More and more people are interested, and we're always in touch with these people. And it's part of our DNA to be part of the project right from the inception. Okay, we are going to celebrate the 60th anniversary. Do you have key dates to share with us? Well, every single employee at CNES has their key dates, but I'm here to tell you about the setting up of CNES 60 years ago. And then 4 years later, the first launch that made it possible for France to become the third space power in the world capable of orbiting a passenger with its own launcher. That was on the 26th of November 1965, and that was the Asterix satellite, a very French name indeed, with the Diamant launcher from the Ameghir base in Algeria. So that was the very beginning of the space journey for France. We started from scratch. We had no space industry, no scientists working in space. No one knew how to build a satellite or launcher, but the army was interested. We worked with them, and we set up the first research labs, the first products. We did lots of things in-house because nothing existed, and then little by little the industry ramped up their expertise, and today we have the ecosystem that we all know. Today we're all focused on the CSG, the Guayana Space Center. When was it opened? It was in 1964. We had not yet launched the Asterix satellite in 1965, but we were already preparing our future base. And on the 24th of December 1979, that was the first launch for Ariane. That was Ariane 1. And then we had the great saga of Ariane flights. You know that we've launched 255 Ariane launches so far. Then June 1982, we launched from Baikonur, and that was the first European to fly in space, Jean-Luc Chrétien, a French cosmonaut. And we have great expertise in manned flight at CNES. In 1986, Spot 1, the first satellite for the Spot series to observe the Earth. And there again, it was a highly innovative satellite back then, and in field of expertise of CNES. So 60 years of presence in the industry for CNES. Thank you so much for your time. Philip Steininger, can you tell us about the major steps for the cooperation between CNES and the Army? CNES was set up 60 years ago, and right at the inception, there was a desire for CNES to be very much involved in military affairs. We wanted France to be a space power, but also for civilian applications, but we also wanted ballistic missiles for our nuclear power. So public authorities were convinced of the usefulness of space and of a strong connection between space and national defense. So CNES is a key player in our national defense. Yes, in our space national defense, for the monitoring of space, for conducting space military programs, and CNES paves the way for the future, for future operations in space. It also controls the military satellites that evolve in low Earth orbits, and it supports the ramping up of the armed forces in the space area. What can you reveal about major programs in the future? Well, CNES is involved in developing the future generation of satellites and in the coming years, CNES is going to continue working in close cooperation with the French Air Command, Space Command. Thank you. So, Philip Steininger, so what about watching this video and tell us a few words about this long journey? Yes, it was a long journey, but we can only pay tribute to the decision made by our politicians 60 years ago. They decided to turn France into a space nation, and within a few years, it became a reality, as in 1965, we launched our first French satellite, and this in total autonomy. And I'd like to underline the constant effort of political authorities in favor of space, meaning that France is one of the key players in space at the moment. Okay, so that's your anniversary. There will be an anniversary for DGA as well. Coming back to you, Samuel Rogers, where do we stand? As we were watching the video, I think there was a notification that we have data from Santa Maria Station in the Essonne. Yes, so we are in the north of the Atlantic Ocean. That's the end of the AVAM phase. The AVAM engine or stage should be turned off in 1 minute. So yes, in less than 1 minute, we'll have the extinction of the AVM stage. It will be reignited a bit later. Okay, and what's coming up after? Okay, so the switching off of the AVM has just been confirmed. I heard it. Confirmation, extinction of the AVM stage. Okay, and after that? Well, after that, we have a long phase taking us all the way above Australia. We'll have no stage ignited anymore. We'll be just flying all the way to Australia. Okay, the announcement that was made said that there is loss of contact with Santa Maria. Sorry, we are in the dark. Yes, we are, but it's all normal. It's nominal. That's something that we know. We expected that. The launcher is going to follow its trajectory, and it will continue taking measurements, recording various parameters, but instead of sending the signal to ground stations, this is stored on board, and this will be collected by the next station, which will be New Norcia in Australia. That's when we will collect all this data. So we just have to wait and wait till the time we are above Australia in 10 minutes. Okay, so we talked about the 60th anniversary of CNES, and this year there is another anniversary, that's DGA. We also have a short newsreel, and then we will come back to you for this next stage.
Hervé Grandjean, back to you. You are the spokesman of the Ministry of the Armed Forces, and since the beginning of this program, we've been talking about the involvement of DGA in CERES. We know the armed forces, but not so much DGA. It's the General Directorate for Armaments, the French procurement agency. What does it mean? 10,000 people working for the Ministry of the Armed Forces. Let me give you a comparison. When you want to build a house, you know you want 3 bedrooms, a big living room, and a bathroom. So you ask an architect to make drawings and to organize the work with artisans, masons, electricians, etc. DGA is this architect. We manage all major, or they manage all major programs, except they don't build houses, but fighter aircraft, ships, nuclear submarines, etc. And they provide a connection between the military who say, I need a satellite, an aircraft, a ship, and the industries that build them. So very often that's with CNES, like today, of course, big links with CNES. Of course, DGA collects all the military requirements and listens to the forces about what they want to do in the field, with what type of armaments, and then they draft specifications, which is what industry is going to manufacture, and then they will work with big industrial groups and SMEs as well, and write the contract, negotiate, say what they need, and obtain the equipment before delivering it to the armed forces. So it's a collaboration between the military, the soldiers who wage war, and industries that make the equipment. So DGA is in Ballard, in Paris, but also in many test centers. We have about 10 test centers with highly qualified engineers that work in these test centers. If you go to Normandy, close to Paris, there are people who draw the propellers of our nuclear submarines. In Angers, people test new armored vehicles on special tracks to make sure that the equipment that will then be used by the soldiers in operations meets its performances. And you have a specialized center in Toulouse as well, absolutely specialized in airspace now. Why Toulouse? I know why, because, well, there are many of you working with space. Well, Toulouse is the beating heart of the space business, and we decided to locate the Space Command in Toulouse when we decided to set up this defense space strategy. We know that satellites are important for this strategy. What we haven't said is that space is becoming a conflict area nowadays. Spies are trying to listen to our satellites. There are firings against satellites that create debris, and that happened very recently. Yesterday, there was maybe a Russian firing, destroying a satellite. So it's very topical. So space is becoming a field of conflicts, and we need to prepare to wage war in space. That's why we have prepared a space defense strategy, which includes developing equipment, nanosatellites, etc. But also there is an operational aspect. How do you get organized to wage war in space? So that's why we've set up a space command that will be located in Toulouse and coordinate with CNES. There is Thales as well and many SMEs, and there will be a coordination there. And it's Toulouse where all this is happening. That's why it was so important for us to locate it there. So I met you at CNES in Paris, but you're also based in Toulouse. Can you explain the role of CNES? You don't only work for defense, but you've had a long collaboration with them. Yes, CNES is a public establishment with an industrial and commercial aspect, and its role is to propose space policies to the government, and once it's approved by the government, CNES implements this space policy, which leads us to having many activities, scientific ones, in defense activities, but also special space applications as well that take us very far. And that's why CNES is under the leadership of different ministries, the one in charge of space, in charge of research, and the one in charge of defense, the Ministry of the Armed Forces, which shows a very wide scope of activities. So what is each of these organizations' role? Is there manager? Are you involved in operational matters? Yes, CNES has three main areas of intervention for the benefit of defense. The first one is that we conduct major space military programs. Second one is preparation of the future. The third one is more operational oriented. It's the surveillance of space, and that's space operations. And the fifth one is to provide support to the armed forces to help them ramp up their capabilities in the field of space, because as was mentioned before, we've started developing a new space strategy in 2019 in the field of defense. The first four areas I've mentioned are traditional, CNES serving defense, but the fifth one is newer to help set up this space defense strategy. Now, regarding today's mission, CNES is in charge of an important mission for CERES, which is the formation flight. That's important, yes, it's important for us, yes. Well, there are 3 satellites flying in formation, but once we've designed and developed the equipment in partnership with the Ministry of the Armed Forces and CNES, we need to guide these satellites. Till now, it was CNES operators that did it, but now we want military men to also guide these satellites because they will be involved in military missions. So it's a joint mission. And again, we thank CNES to help the Ministry of the Armed Forces in this activity. But in the future, the CERES satellites will be led by mixed teams. And that's a very interesting idea. You don't imagine that you need to pilot satellites. They fly in formation. We're going to watch a video to understand how these 3 satellites are going to fly in formation and understand better in this video.
Bueno, gente, yo
It's
en breve
a major
está finalizando
development
el
on which
directo.
the CNES engineers have been working for many years
Tuvimos
to multiply the
lanzamiento
performances,
por ahora
push the limits.
exitoso y
It was a big
solo queda la
challenge because the
separación de los
future of many
satélites
Earth
en
orbit
minuto
missions and also
58,
remote
si no me
orbits
equivoco.
are based on formation flight.
Sí,
And
56 o
Toulouse, Paula and
58.
Geraldine are heading the departments that have provided this technical development. Formation flight involve a number of satellites that are flying at a very close distance. Now, we can make a difference between different formation flights. Some of them involve a series of satellites that can have different designs that are scattered on the same orbit but not very close distance. Now, we can make a difference between different formation flights. Some of them involve a series of satellites that can have different designs that are scattered on the same orbit but not close. It's called the trade. For CERES, you have 3 satellites flying on 2 different orbital plans, and that constitute a specific geometry, a triangle that you need to maintain throughout the mission. You could mix up formation and constellation. The difference is that the constellation involves a series of